Well, good afternoon, everyone. My name is Kevin Mickey. I would like to welcome you to URISA's webinar. Before I introduce our speaker today, I'm going to share a little bit about URISA and what we have coming up, which I hope you are able to take full advantage of. As I said, my name is Kevin Mickey. I have the honor of being a URISA past president and currently co-chair the URISA Community Resilience Work Group, which is responsible for putting on and hosting this webinar and a number of others in an ongoing series about topics related to community resilience, natural hazards, and other related items. We have lots of things going on in URISA, as always, one of which is a salary survey that we do periodically, which explores and collects information about the GIS community that is published in the form of a geospatial salary report. We would love to have your input into that report. So please take advantage of that. You see a code here on the screen. Please use your phone. I'll leave that up for just a moment. Hover over that, and you can get access to that survey. We sincerely hope you take advantage of that. We have a number of webinars coming up, and this list is constantly changing. In fact, it was added to even this morning, and there are many more coming up. In August, we have two events coming up, one of which is the on-demand custom topographic maps with the Topo Builder application from a speaker as today is the case from the USGS. And on August the 20th, we'll be welcoming a presenter from the University of San Diego who will talk about how they're applying ArcGIS story maps to facilitate collaboration and knowledge sharing with the communities that they serve. URISA does far more than webinars. One of the things that we're very proud of and have many individuals who have successfully completed our leadership academies. This is your opportunity to develop skills in leadership that can help you develop and manage programs for your organization and grow your own professional experience. These leadership academies are in-person events. They take place at locations around the country. And we have one coming up now in November in Fort Worth, and an advanced leadership academy, which is a recent addition to our portfolio that's occurring in Chicago, Illinois in August 12th to 16th. And then in December, we'll have a virtual version of our Leadership Academy that'll be occurring in the early part of December, and the registration for that will be opening soon. So visit URISA's website, urisa.org, to find out more information about that. And I would hate to not mention one of the greatest events of the year. I always look forward to this, and that is our annual GIS Pro Conference. This year it occurs in beautiful Portland, Maine in early October from the 7th to the 10th. This is URISA's 62nd annual conference, which I'm just delighted to be able to share with you. This is just a testimony to the power of the geospatial community and its collaboration, and how successfully URISA has supported that community over the years. This is your chance to come together with your peers, with experts in the profession, to learn new developments in the technology and in the application of it and how we use it to serve the communities that we work with and for. So don't miss that event. And then lastly, if you're not currently a URISA member, I'll share with you that one of the most valuable aspects of membership to me is the opportunity to connect with others in the profession. We help that occur in lots of different ways. Even though we're dispersed across the globe, we are individuals that try to stay and successfully stay connected on an ongoing basis through a variety of means, such as the webinar you're experiencing today, an online networking presence, and ongoing conferences and other activities. So if you'd like to learn more about URISA, simply reach out, visit our website. I or anyone else that's associated with the organization will be delighted to chat with you. So what comes next? I am delighted to be able to share with you today that we have, I think, one of the best speakers I've heard in a long time. I know I'm embarrassing Marie, but I mean that sincerely. Marie Peppler is with the U.S. Geological Survey. I had the opportunity of hearing her talk recently on some of the things that she's going to be sharing with you, and I am excited to hear what she has to say. I think we'll all benefit from learning about the amazing resources that the USGS has to offer, how we can leverage them to support the communities. And I know Maria is always interested in hearing ideas from other people for how they can continue to improve their already fantastic services. So that's enough for me. Maria, I am going to turn this over to you. If you'd like to share your screen, the floor is yours. One other thing that I will mention before we get going is Marie loves questions. You're muted. Everyone is muted by default, but we encourage you to post any questions that you have in the Q&A, and I know Marie will get to each of those as much as possible throughout the presentation. So, Marie, the floor is yours, and thank you so much for being here today.
Thank you so much, Kevin. Am I unmuted? Am I good?
You're good to go.
Okay, thank you. And thank you, Kevin, for the introduction, and the flattery will get you everywhere. Yeah, this is a talk that I have given multiple times. It really speaks to my breadth of how much I love USGS and the hazards that we talk about, and how much the resources can help emergency managers and any sort of practitioner really access our data. So I'm going to talk about sort of hazards 101. I'm going to go through several different hazards here today, and how you can access the data and the tools that we provide is really the focus of the talk. And so let's get started. And again, thank you. Zoom is not my normal video conferencing. So if I get a little sideways, thank you for your forgiveness. I'm just going to speak very briefly. USGS really looks at natural hazards and their intersection with society, and how we can both look at observations in the landscape and really have those instruments directly on the surface of the earth and beyond. I'll talk about that too. And really help promote understanding and situational awareness of those hazards, being that sort of primary information in a lot of different ways. And by bringing both the hazards and the societal impacts, that's really where emergency management sits, and those risk research and applications. How can we deliver that data in a way that it is usable and relevant to society? And as Kevin mentioned, I love feedback. So if anybody has an idea, like, man, if you tweak to this way, I could use it better, please email me. My contact information is going to be at the end. And of course, I think it'll come out with the slides and such. So let's see if I can do both screens at once. There we are. So this talk today is going to sort of mirror one of my key information products. We have a 2-page fact sheet that sort of steps through each of these hazards and the resources that we provide for emergency management. The hotline and the QR code to link to this website will be available at the end. And like I said, I'm going to work through each hazard. So if you do have questions on each individual hazard, please ask as we go along in the chat, or I have no idea. I should have asked Danielle if I can like unmute and actually talk to people or not. If we can't, that's fine. I can work with the chat. But ask as we go along. We can certainly go back, but keep the ideas coming so we don't cycle through everything all at once. But let's start with earthquakes. The thing that USGS is, whoops, wrong screen. Sorry, hang on, there we go. USGS is most associated with earthquakes for a lot of people. USGS runs the Global Seismographic Network, which is at its core is 150 sort of core key locations, but then we work with high quality data provided by regional networks around the world to really refine that information and to be able to provide those products. These include sites above the Arctic Circle, at the South Pole, and literally everywhere in between. As those waves echo around the globe, the network is distributed so that we can measure them as best we can. We also provide the National Seismic Hazard Model. This is a key data layer where it shows what is your risk locally around seismic hazards. And this takes a lot of different things into account, not only the type of rock, the type of faulting you have, how frequently the earthquakes occur, and puts all of that together in sort of a very easy to use, dark red is bad, green is less bad, right? Type of model associated with this. In the upcoming year, I believe 2024 and 2025, we are including Puerto Rico, and the states and territory, or additional US territories will be included in this model in the future. So now that we know what our risk is and where we are and how we can measure it, what sorts of products can you expect when an earthquake happens? So years before, we talked about the seismic hazard analysis and forecasting and how can we work towards before the earthquake. But most of our products, because earthquakes can't be predicted no matter what you read on the internet, really come from the earthquake forward. We do have shake alert, and I will talk about shake alert at the end here, but you're really looking at a whole series of products that develop instantaneously following the earthquake using some automated systems, and then work forward in time as we develop more and more products. They're checked by our on-duty seismologists that are around 24/7 and provide more detailed information about the system. So I will say too that not all the information shows up right away, right? You have to remember that in an earthquake, it takes time for those energy waves to bounce around the earth and refine that mathematical part of it. And we take time to take that final information and intersect it with the human information in Pager, which I'll talk about too. So when an earthquake happens, you can, When an earthquake happens, you can click and find the page. How you get to this page varies by person. Some people receive automated alerts on their phones. Some people may just feel an earthquake and find out about it in the news and Google. This is sort of our landing page for every earthquake. And this is a rather large earthquake near a populated area in California, a 6.4. So it has all of the products associated with it. Sometimes you'll come to our site web pages and only see a portion of the products associated with any individual event. Because if they're not big enough to trigger certain things, we're not gonna do those products. So the products are sort of divided into types. Earthquake shaking is sort of the centerpiece. How much am I going to feel? What intensity am I experiencing? And we do have a citizen science project called Did You Feel It, where we actually take information from people who fill out the form online that says things like, my car shook when I was sitting in it, or my plates fell out of the cupboard. And those things really get to real scientific information about what sort of impacts were felt at that location. We have information about the earthquake impact. So Pager, Prompt Assessment of Global Earthquakes for Response is that acronym. And I'll go into detail on that in the next slide, but ground failure information, whether or not we expect landslides to be triggered or liquefaction to be observed, those are additional GIS products that can be pulled into a map and show the likelihood of those areas with those particular hazards. There's information about the earthquake source, how deep was it, what type of fault was involved, and what type of energy was released. Then we have sort of additional threats is what I look at, the last piece here for earthquake threats. Aftershocks, what are those next shakes that we might expect to happen? And is there a tsunami risk with this particular event? The rule of thumb is if a earthquake is less than 7, odds of an earthquake-induced tsunami are low, but there are other things that induce tsunamis, such as underwater landslides and volcanic eruptions. So tsunamis are not a known thing in any given event. So shake alert, earthquake early warning. What does this look like? If there's anyone here from California, Washington, or Oregon, those West Coast states, you are participants in Shake Alert, the earthquake early warning system. And what it does is it takes advantage of the fact that earthquakes consist of sort of 2 pieces, that really fast P wave, those primary waves, and then those damaging secondary waves are what really, where most of the energy is contained. And essentially we can do an alerting system. Those first P waves can alert systems, and the warning can be anywhere from 5 to 10 seconds up to 45 or 50 seconds if you're far enough away. And we can do things like turn off natural gas lines, open doors on fire departments, and stop automated surgeries. Personally, if I knew an earthquake was coming, I would want that surgery to stop. It's a really good plan. So operating rooms and hospitals are very much connected to things like Shake Alert. Individuals can take actions like duck, cover, and hold on. And these do go out through the wireless emergency alert system. This is not something that USGS does alone, that's for sure. This is a big partnership about how to get these alerts out and have people take action in advance of the earthquake. So if you do live in these areas or are traveling to these areas, I recommend you download the app, register, get the alerts on your phone, turn on those emergency alerts, and be connected. I feel like I'm going very fast and there are no questions yet, so maybe we're okay. I did promise we were going to talk about Pager. This is actually, if I'm allowed to have a favorite, this is one of my favorite products that we put out. Pager really takes that shake map, that map of the intensity where the energy is going to be concentrated in the earthquake, and intersects it with the people components of the earthquake. This one here you're seeing is a red, that's the highest category. And this was for the 7.8 magnitude earthquake in Nepal several years ago, which was absolutely devastating to the area. And it marries the, like I said, the people and the shaking. So, and it looks for, based on the type of buildings, the type of processes that are coming along. This is the, this is the Turkey earthquake that I switched to here. Looks at marrying how many people we expect to be killed by the earthquake and what are the economic losses of the earthquake. So these can also trigger additional actions. If we have a pager red earthquake in the domestic US, many emergency management operations centers simply activate to their full potential. They know that when we put out a red pager alert, that the impacts are going to be significant. And every time we experience an earthquake, we go back and refine these models and connect them back together and make sure that we're checking and refining everything, because globally this is a real challenge to correct for building construction types and such like that. So, all right. Any questions on Pager? Oh, wait, I've got 2 questions in here. Hang on a sec. Oh, so for Jane, the app you need to download depends on where you are. Each state sort of has a different group. So search on your phone, contact your local emergency management group, search like your county or state emergency management, and they'll direct you to the right spot for your earthquake early warning alert. And then Alice asked, are there live GIS data a community can consume and share before, during, after an event, an earthquake? Yes, absolutely. So almost all of these, hang on, here we go. Almost all of these products are available as GIS layers. When you click on this interactive map, I'm pointing on my screen like you guys can see. I'm sorry, that's my bad. The interactive map over here in the upper left does link, and if you scroll down in the page, there are links to the GIS services for any of these products. And the interactive map services does also have, I don't know what the right term is. I'm sorry, I've been out of the GIS world for way too long. There's web services that update themselves automatically. And those are what you probably want to aim for loading into your mapping applications for that situational awareness. So there's a whole section on earthquakes.usgs.gov about that'll include all those geospatial links and layers and how to use them. There's tools about how to integrate them and how to use them properly, what to expect, how often are they updated, those sorts of things. Really good question. And I think I have that link on my webpage on the link that I sent in the chat, and will also be at the end too. Good questions. All right, we have 2 more quick things to talk about for earthquakes before we move on to the next one. So keep the earthquake questions coming. I'm going to speak really briefly about operational aftershock forecasts. This has not been operational very long, so my slides aren't terrifically exciting because we haven't had very many of them to integrate. I should work on getting better slides. But what this is shortly after the earthquake occurs, the aftershock forecast is put out, and essentially it shows the probability of each magnitude level, 3, 4, 5, 6, and in this case 7, of occurring in the given time period. So here, this chart is what's the likelihood of an aftershock within the next week within the designated area. And for domestic earthquakes, we do map those. We show an area. Sorry, this earthquake happened to be in the Aleutian Islands, so the map's not particularly interesting, just a lot of islands. And this product is really crucial for planning how you can recover. At what point are we comfortable with the risk of an additional aftershock triggering? So can we conduct things like building inspections? Can we, when is it sort of safe to allow people to return to their homes? Is a very difficult judgment call. When do we retain search and rescue personnel very close because we're worried about the next aftershock? Or do we allow those search and rescue people to go to their regular standing availability? And personally, I think they give a lot of peace of mind, right? People following earthquakes tend to sleep outside. They don't want to go back in their homes. And these types of products and information can really help reassure people that the probability of an earthquake is decreasing. Note that each sequence is different and unique, but mathematically consistent. So they tend to, once the aftershock sequence sort of gets its, I like to say gets its personality, the forecast can really show that the decreasing sequence. All right, hang on. What's the question? Oh, good question, Kevin, about does USGS model estimated damage from aftershocks that consider already damaged structures? So the answer to that is an easy no. That's a really difficult consideration. And we know that subsequent pagers that are issued in a sequence are less accurate than the first pager in this sequence. So that's where people get involved and help refine those damage estimates and communicate different products on that particular earthquake sequence. Really good question, really difficult challenge. Pager does use HAZUS, which I think you guys, Kevin and Shane for sure are familiar with. So it does work with sort of the general building stock, and as usual, with as good as the information is locally in HAZUS is how good Pager is going to come up with. When the community is rebuilt and different building codes and building stock information are loaded into HAZUS, that's automatically added into the pagers that are generated. Good question. All right, any other questions on that? Okay. Two more. I have one really, this is sort of a, I think this is one of my favorite slides as the geologist and geomorphologist that I am, is did you feel it? How do earthquakes differ for different parts of the US? And Kevin, being that you're sitting in Indiana, you recognize that it actually has a pretty high risk of seismic activity, especially to the southern portion of the state. But the eastern US you can think of as cold and old rocks, and the western US are sort of young and hot rocks, and they move differently, and earthquakes respond differently in this location. So these are two relatively equal magnitude earthquakes. How did you feel it? Activity where people were participating, did you feel it? And you'll see that earthquakes are just not felt as widely on the West Coast as they are on the East Coast. So East Coast earthquakes are going to be felt because the rocks ring like a bell across the way. And I think that's a really important distinction when you're looking at how you how people talk about earthquake risk. Yeah. Okay. Question, Kevin, you turned on your camera. You good?
Yeah, I'm good. I was actually just going to tell you real quick, Marie, your audio was a little bouncy, but you're back again.
It is my network connection, and I'm in the office. So Let's blame Microsoft. You know?
I'm good with that.
Yeah. Yeah.
Thanks, Marie.
Okay. All right, cool. I'm sorry. I'll do my best. All right, the last earthquake product that I want to talk about here today is ShakeCast. ShakeCast is actually a model that can be done immediately following an earthquake. And if you work for a group like a municipality public utility type groups would want to work with us and work with the ShapeCast products. Essentially what you do is you load all of your critical infrastructure into ShapeCast ahead of time. Bridges, like shown here, a power plant. And then you run ShapeCast immediately following the earthquake with that particular earthquake's information. And it gives you a prioritized list of expected damages to your critical infrastructure. So it's not something we provide to the public. It's not something that is available online already, but I mention it here and I go to earthquakes.usgs.gov and look at ShapeCast. I think it's a really critical product that can work for this, maybe your community as well. Okay. Oh, Judith mentioned you may not report because you are used to earthquakes as more often in the West. I think that's probably true too. Your building codes are very different. I sit here in Reston, Virginia, just outside of DC, and my house is not earthquake retrofit. Our facility that I sit here on our headquarters is not seismic retrofit at all. So your buildings, facilities, and personal preparedness and comfort with individual hazards are very different. That's an important point. Okay, any last questions on earthquakes before we cruise over to wet hazards? Okay. So USGS is the largest surface water monitoring network in the US. Some states and towns and counties also run their own. Army Corps of Engineers also runs their own, but USGS runs 11,000 real-time surface water discharge sites, supported by almost 1,000 hydrotechs, and they are just my favorite. I'm a water person by nature, and our stream gauge network is half funded by federal appropriations and about half reimbursable by 850 different partners that want to rely on our data to make their critical decisions. Stream gauges, our #1 partner is the Weather Service. They're used to support the flood forecast. So when you see the predictions online that the river's going to crest at 16 feet tomorrow, they're relying those observations. The observation side is the USGS, and the weather predictions are made by the Weather Service. So if you take one thing away from this, is that the National Weather Service doesn't have stream gauges, although everyone thinks they do because they go to their website to see them. The perfect interoperable data sharing, where they provide the data on their webpage and the public only has to go to one place to get that information. So the stream gauges do the measuring, the Weather Service measures and forecasts the rainfall, goes together in a model, and we produce those predictions. These predictions are also going to come up later when we talk about landslides, so keep that in mind. Our water products are primarily available via the National Water Dashboard. That's the centerpiece product. The colors here represent deviation from daily normal. So for this day that I took the screenshot, which I don't remember when it was, you can see some drought out west, some flooding in the Pacific Northwest, flooding in the central states, although that may not be flooding in the normal sense, just more wet than that area was for that day. These data also are all available via web services and ready to integrate into your applications as well. Both the sort of national site layer and the individual site statistics, which not only includes stream flow and stream height, that also includes water quality, precipitation, additional the groundwater data set is fantastic and really can provide a lot of information about drought status. And actually we see the earthquakes and the groundwater discussions too, but we'll leave that for another day. Oh my gosh. Okay. Hey, hang on. Microsoft just told me I have to update to Windows 11. So let's really hope that doesn't happen in the next 30 minutes. So, sorry. All right, so that was surface water. We're going to cruise here to coastal storms. USGS supports this particular one is how we supported Hurricane Matthew, and we deploy additional instrumentation around the stream gauges in to support the detailed information needed by the National Hurricane Center and our partners at NOAA and other hurricane groups to document the unique impacts of a hurricane on the water. That's a mix of inland flooding and coastal inundation. You can see the map on the left here shows the red dots are all the additional sensors that nest in and amongst our stream gauges, which are the teal dots on the right map, and sort of augment that coastal area. The blue marks here are called high water marks. They're measured after the storm, and both in inland and coastal communities, as you can see here, Hurricane Matthew specifically impacted North Carolina and South Carolina. And those high water marks can be used to calibrate models and confirm things like insurance studies or other operational needs. There is an endless list about what can happen with high water marks. That is, I'll give a whole separate presentation on that one. It's one of my favorites. Other coastal products that we provide. Oh, sorry, I should have said these are all available. Maybe I can't go back. There we go. All of these data are available via web service as well. The services are set up for each individual storm. So you kind of have to know which storm it is and head into those data services layers and load that particular data. They aren't static layers because we do deploy differently for each storm. Okay. Next, and this is another really fantastic data set, the real-time coastal change forecasts. I personally call these the red ribbon maps or the bacon strips that are modeled out along the coast. And what you're seeing are the probabilities of dune erosion, collision, overwash, and inundation. Sorry. Sort of what's the likelihood of that photograph on the right here at Kitty Hawk, North Carolina. What's the likelihood that that's going to happen to your dune focus? So what you see here is a model that's put out in conjunction with the National Hurricane Center forecast. So when those forecasts for coastal products kick in, these models are run and they can really tell local communities what they can expect as far as impacts. Obviously, collision with the dune is preferred over full inundation and potentially a breakthrough erosion situation. Every time I see this picture, I wonder what that person was thinking when they drove through that. Like, just turn right and go around, I guess. I don't know. But yeah, this can lead to supporting evacuations and supporting additional processes. All right. Any questions on coastal and flooding before I move on to landslides? Okay. All right, landslide hazards. Landslide hazards are kind of a little bit different in the USGS. They're younger. The National Landslide Hazards Preparedness Act was just passed a few years ago. So this is what I'd call a sort of developing program, maturing. And they deliver landslide assessments, tools, and data to assist in a variety of landslide crises. These models and maps are associated with remote sensing, how we can kind of help determine the risk or local floods, the products that we put out. The Spanish language guidebook that's listed here on the right was put out following Hurricane Maria in Puerto Rico, which resulted in, I don't remember, it's like 50,000 individual landslides on the island of Puerto Rico. Landslides I also like to call the first secondary hazard with all of the other hazards. They can be triggered by flooding, earthquakes, high winds stripping vegetation and changing that equation. They can be post-wildfire landslides are actually 2 slides from here and are what we're dealing with just this week. Landslides can also be sort of the large primary hazards, such as in Oso, Washington in 2014. USGS supported active monitoring of the landslide stability in order to support both search and rescue and search and recovery efforts in Oso. Landslides also of this magnitude, you can see here it dammed up the river and then caused an outbreak flood. USGS also provided information and supported with that process. Luckily, these are few and far between. The much more common landslide hazard these days especially are those post-wildfire landslide hazards. We have an active operational mapping program that works with burn area response and provides risk maps associated with the individual fires and their burn severity and what is the likelihood of those areas to activate a landslide with their first rainfall flush. And those products are also available as GIS layers and can be used for, typically they're valid for the first few years following a flood, following a fire. That elevated risk is still in play. And what do we do with those particular maps? Well, this is a town that would certainly be at risk following a flood and a mud flow. And USGS works with the local National Weather Service offices to provide those risk maps and then provide those thresholds for initiating those debris flows. So given these parameters, we expect this intensity of rainfall has the likelihood of triggering a landslide. And then National Weather Service takes that information and issues those flash flood, landslide, mud flow watches that are particularly relevant in the steep, heavily populated areas. We had a very unique opportunity going on in New Mexico right now, where it was actually raining on top of the active fire. Most of the time we call these post-fire debris flow analyses, not during fire debris flow analyses. But when the rain and thunderstorms were occurring within the active fire zone, we found that the fire and the floods and the debris flows were all occurring at the same time, leading to a very complicated situation for our technicians and for the weather service and the emergency managers. Okay, any questions on debris flows and landslides before I move on to, we've got volcanoes up next. All right, seeing none, let's talk about volcano hazards. Volcano hazards also trigger landslides and debris flows, but in addition to that, they have all sorts of hazards that you normally think of, ash clouds, lava flows, but they might also be different. Lahars, those fast moving mud and debris flows of superheated, basically mud. They're scary. They're typical in the Cascades. Slow, relatively easier to manage and keep away from lava flows in Hawaii. The speed is slower, generally speaking, not always, but most of the time. The eruption in 2018 in Kilauea, I think I've got some pictures of that later, resulted in no fatalities and only a few injuries because we were able to warn the public and keep people away from the area. And ash-laden eruption clouds in Alaska, that's a particular hazard there for the aviation industry. Thousands of people fly over the Aleutian Islands every day, and if volcanic ash were to interact with an airplane, that is a I don't want to say guaranteed crash, but pretty much. So we work with the Federal Aviation Agency to help keep pilots and planes away from active volcanoes, of which in any given time, I think there are currently two or three in the Aleutian Islands that are actively erupting. So, I'm sorry, I got ahead of myself in my slides. So you'll look here, these volcanoes are colored by their observatory that monitors them. So we have 5 total looking at the Alaska Volcano Observatory, which includes CNMI Islands. The Cascades Volcano Observatory includes a lot of the high hazard volcanoes. So that's going to be Mount Rainier and Mount St. Helens. Hawaii Volcano Observatory is, of course, Kilauea, the most active of them all. California Volcano Observatory monitors the Central California area and is co-located with the Yellowstone Volcano Observatory that looks at the volcanoes in the Intermountain West. And we did have an eruptive event at Yellowstone I think it was last week, maybe it was this week, last week. And the head scientist for Yellowstone said, oh yeah, that's what Yellowstone does. It does these sort of steam bursts. And we're very grateful no one was hurt in that particular event. So volcano monitoring methods, these data are also available, but I don't recommend connecting them to your applications in their raw form. Information from satellite remote sensing and gas monitoring really gets distilled down into the information products that we put out that sort of give the watch warning colors for any individual volcano. And those watch warning colors are much more useful as in the aggregate. And that's what I would recommend linking to in your applications to look at volcano hazards. Let's see, any questions on that so far? Okay, I'm actually going to skip my next slide and go to the volcano hazards maps. This is a non-real-time product that we have for a few volcanoes, and it really depends on what area you're interested in. This one in particular shows the Mount Rainier Lahar risk maps, and you'll see that these superheated mud flows that can be triggered by eruptions on Mount Rainier come from the rapid melting of the glaciers that live on the top of the volcano and sweep superheated mud and rocks into essentially the river valleys. And there is a warning time associated with lahars. If our monitoring sees it fast enough and those cities are far enough away, such as Tacona, all the way out on the sea, they could have as much as 45 minutes to an hour's warning associated with these lahars. So these types of maps communicating what is that community's risk, how much time do they have to prepare their evacuations, and how to move forward with those lahars are really powerful products. Some of the communities around Mount Rainier, I think just a few months ago, held the very first and largest lahar drill, where they evacuated an entire community's worth of schools and walked the mile uphill to a safe zone, or what's thought to be a safe zone in their particular lahar model. All of these communities are sort of built on different deposits from Mount Rainier, lahars being the most time sensitive and dangerous. Any questions on lahars? Okay. Oh, I forgot I had this last slide in here. Sorry, the relationship of volcano and regional seismic networks. This is where USGS has a really unique look at things. You'll see here that the seismic stations in the white triangles are sort of spread throughout the area, but then we have sort of these dense networks of seismic stations around some of the volcanoes, but not all of them. And you'll see that Mount Adams, which is considered a high threat volcano, doesn't have a ton of instrumentation around it. So the volcano program partners with the seismic program and the regional seismic networks in California and Washington and Oregon to gain additional information about the volcanoes less monitored. And I think it's important to note that not every volcano is monitored as much as Mount St. Helens or Mount Rainier or even Mount Hood. And it really takes a big collaborative effort to provide all of this different varied data types around those individual hazards. Okay, any questions on volcanoes? All right, we're going to take our last 3 slides here, not to talk about any particular hazard, but to talk about some general geospatial products that USGS provides. USGS funds the federal 3D elevation program for LiDAR. And apologies, this map is really old. I have not been able to locate a new one in a while. But this talks sort of about LiDAR status, and USGS is the national repository for federal freely available LiDAR information. We lead the elevation and data collection for many federal agencies, use our procurement and contractors for that. We encourage local communities that are considering collecting LiDAR to give us a call. We have regional liaisons to partner with and be able to collect additional LiDAR on top of another collection. We really like to amplify other collections and make sure that we're getting the most out of them that we can. So again, this is all publicly available. We do some post-event elevation data collection, especially around things like volcanic eruptions, coastal storms, where we've got a lot of coastline change. So be sure to check back for those types of things. And again, if anybody has any questions or how to connect to your local geospatial liaison to get connected to the 3DEP program, I'm happy to share that as well. Additionally, we have the Hazards Data Distribution System Explorer. It's a mouthful, so we call it HDDS. The HDDS looks at all of the international and interagency remotely sensed data sets. So this is satellites that are not just the US. In a large disaster, the International Charter is activated, which is a partnership of all the global observation satellites. They kind of partner together during a disaster to provide additional data to each other, to that country that's affected, because the satellites are always scooching around and not always providing the best coverage. But as a group, we can do better. And so this is a charter activation. USGS manages this charter and can provide all of these remote satellite images in an event by event format. So you kind of subscribe to that individual event. And then they do also, sort of as time goes on, the analysts around HDDS do pull historical imagery and scenes as well and include it in that particular event, so it can kind of give you that perspective and support that process. All right, any questions about those two big geospatial sets? Okay. Quiet group, but we're clipping right along. So I also sort of do these three as the public service announcement here at the end of my talk, to say that we have free subscription services that are available to you either in a work capacity or a personal capacity. Water Alert gives you text alerts or emails for the stream gauge near you or the stream gauge that you care about. Earthquake notification service and volcano notification services are fully customizable subscription services where you can say, I want to find out about this particular volcano or all the volcanoes in this region, or get alerted for earthquakes above a certain magnitude in a particular area. So I really encourage everyone to sign up as part of their preparedness plan and just being ready for anything. I think that's our goal. And with that, I forgot one last slide, which is I'm happy to talk about any of these other topics as well. I really focused on sort of our top hazards and the ones where we have the most information. But USGS does work in a lot of other locations. Spills, especially harmful algal blooms, zoonotic disease outbreaks, is an emerging, I won't say emerging anymore, post-pandemic, and which the H5N1 current outbreak. Environmental health and space weather. So I'm happy to take any questions. And here is the QR code that goes to that webpage that I talked about, or usgs.gov/em-resources is where you can find links to all of the links that I shared today. And yeah, Kevin and Danielle will share the slides with the recording.
Marie, I'm optimistic that there's going to be additional questions, but I just wanted to share a couple of observations, if you don't mind. Many of the folks that I think are on this call today are county GIS coordinators, representatives that work for state government, and so forth. This is a rare opportunity to have someone of Marie's caliber available to us today. So if you've got questions about these resources, there is no better opportunity than you're going to find right now. I definitely encourage you to think about them. Many of you are involved in activities such as county hazard mitigation planning, disaster operations support within your communities. In all likelihood, some of the resources you've been tapping are sourced from the USGS, which is, of course, the lead federal science agency. So if you've got questions about data that you've been looking for, you don't know where to find, I would venture to guess, as many years as I've been in this field, I learned new things from Marie when I first saw this presentation. In fact, I learned something new today, in fact, about the aftershocks, as Marie could probably tell from my question. I'll follow up. So take advantage of that, please. Are there any questions?
None so far. And you know what, Kevin, USGS is, here's your trivia fact of the day. We have over 400 offices in every state. We are a 3 hours drive from any stream gauge is the goal. It's not perfect, which means that there's a USGSer in your community. And while I'm at the national level and focused on all the different hazards, if you have a particular hazard or you're in a particular location, I can certainly connect you with the local USGS office or the one associated with the hazard you're interested in to get you that local support. Our water science centers in particular are very active at the local, state, and county community levels because that's where the floods happen. That's where the work gets done. So
The other thing that I found really interesting, Marie, and this is where my own knowledge expanded, was a grasp of just how wide the science mission is of USGS. Traditionally, I think people think water, earthquake primarily, but you covered many other hazards that people may not intuitively think of, including biological, for example, that you mentioned on that last slide. So if anyone has any questions about the role the USGS plays in those areas, either as lead agency or my guess is in some cases supporting agency, for those sciences, this again is your opportunity to broach the topic. Please do.
You know, Kevin, I've worked here for 22 years. I started when I was 5 years old, clearly. And I just 2 weeks ago learned about an entire new program that I had no idea existed. It's an eDNA. They're working on making an operational eDNA observational network that will basically be advanced warnings when invasive species are heading into a watershed or area, specifically with like the Great Lakes in mind, right? So when those species end up somewhere they're not supposed to be, we can do sort of an advanced detection watch warning. And I was like, I can't believe we have the science and the scientists to come up with something as creative as that. It's really amazing. And I just learned that last week.
That is cool. Marie, we just got one of those really
Great.
great questions. I know you're going to love this one. You see
Yes.
Rachel's question in the chat. Does USGS have an aerial imagery program to do post-disaster event collection?
Yeah, so really good question. And that depends on how you define aerial imagery. So we do, the HDDS is the main focal point for all sort of satellite remote data collections, although they do include additional things such as anything from drone data to UAS data that's collected by FEMA and the Civil Air Patrol partners to NOAA's aerial imagery and surveys. We serve those as well. So we can sort of be not necessarily our program. We do plenty of collects and we do that. But the NOAA imagery can also be served in our application too. We try to be the one-stop shop for a lot of different federal products as much as we can pull together during events. And that's that really good partnership through both the NGA and our federal groups. So
thanks for posting that link, Shane. Something else I know that came up prior to this call is there's an ongoing interest from state and local government, I know, to know how they can collaborate with USGS, how they can inform their products. I don't know if you might want to speak to that, because there's a lot of really talented GIS people on this call that do a lot of great work. And, how does that fit? I think Alice's question is, possibly speaking to that. I'm delighted to see these questions coming in. I'm going to stop talking and let Marie just run with this.
Yeah. So, Forest Service, I'm not going to speak for Forest Service. Sorry, Craig, I'm just not going to answer your question because I don't know. But I can connect you with my emergency management counterpart at Forest Service if you're interested in connecting with them for their geospatial products. All right, Alice asked, I'm a local government rep to statewide representative, has a USGS rep too. Do I do this presentation to a state JIC? I could. I certainly could, but I'd actually recommend that you contact your local USGS office and get your local geospatial liaison through our National Geospatial Program, NGP. And I can provide them the slides, I can work with them, and it's better to have an in-person connection. So statewide, I'd recommend sort of your local geospatial liaison or your local water science center as a starting place. And Alice, I'm happy to connect you with those people for your location if you shoot me an email. All right, Danielle. Oh, Craig wanted to know for USGS. Sorry. Oh my gosh, it's like such a triggering thing that I don't step on other agency toes, but I get the typo. Building GIS capacity, yes. And then actually, Craig, it's sort of the same answer that I had for Alice, which is to work with your local geospatial liaison. They're the ones who both coordinate the LiDAR program that I talked about, but they also do so much more. They can help you get access to information. They can also provide feedback back to other parts of the USGS so we can format services and products better for you and kind of make that greater connection as well. I should just get that liaison link, and I'll be sure to include it for everybody with the products that I provide back to Kevin and Danielle too. All right, any other questions? We've got a couple more minutes. Okay. Oh gosh, let me stop sharing my screen. There we are. Hey.
Thanks for putting that link in there, Craig. I was actually sitting here looking for that myself.
Nailed it. Google to the rescue. All right.
I can speak to, and I think many of you could do the same. If you've not made a friend and learned who your USGS liaison is, you need to do so. Many times, I know in the region that I live in, our USGS liaison has been incredibly valuable. They participate in state GIS working groups. Often they participate at conferences. They usually collaborate on multi-agency entities such as the Silver Jackets, for example. They are not just the voice of the government, they are the partnership, they're the connection between the community. And I think, I think I can comfortably say, at least in my experience, that our liaison is representative of the others in the country. So that's a great partner. I can't really emphasize that enough in my.
It's really good to hear, Kevin. And you know what? They reach back to the rest of us too, right? We really come to it with a one USGS philosophy. So they're that great partner. And then, like you said, they bring in everybody else that you need. So they're a good start. And I'm really glad Rachel already knows hers. Points. Good job.
Well, we're coming up to the top of the hour. Marie, you included your contact information. I know you did that sincerely. Yep. So if anybody has any questions you want to follow up with Marie on, then please do that. Make sure you reach out to your liaison. USGS resources are not static. They're always changing. Every time I see a presentation of this type, there's something new. Don't miss that opportunity. I'm really impressed with just how much work our science agencies have done, certainly with the USGS being one of the leaders in that area. So, Maria, I know you have a really busy schedule. I sincerely appreciate you taking the time out today to talk to our community, and I look forward to hearing from you again in the future. So thanks again, and I think we'll call it a wrap.